Every time you open an app or click a link, thousands of distinct computers talk to each other to deliver what you need. Behind the scenes, these machines have to constantly figure out how to create, translate, and upgrade software on the fly, entirely over the internet. Middleware is the engine under the hood of this movement. It is a layer of software that relies on a specific set of strategies known as the master builder's playbook, the specific software patterns that keep data moving. In software architecture, a pattern is a proven, highly repeatable blueprint. When engineers run into a common communication problem across a network, they pull out a specific pattern designed to solve exactly that issue. Learning just 3 of these patterns illustrates how systems that don't speak the same language can still collaborate perfectly across a network, as if they were part of the same program. Let's start with the first hurdle, creating things. Computers frequently need a way to ask another machine across the network to create a new software object. The problem is, the requesting computer usually doesn't know the exact technical details required to build it. Imagine a digital toy factory. You don't need to know how to weld or operate machinery. You simply slide a piece of paper under the door that says, "I need a red car," and the factory handles the assembly, eventually handing you the specific toy you asked for. In our network, that magic factory is an actual software construct sitting on a server rack. This sequence diagram lays out exactly how this works, using what we call the abstract factory pattern. The client on the left sends a generic creation request over to the factory. The factory itself represents a general set of rules, and it defers the actual heavy lifting to a concrete factory behind the scenes to create the object. Once the object is created, the factory passes an object reference back across the network to the client. The client now has a direct line to use that remote application instance, without ever touching the raw code used to build it. This separates the request from the assembly. The factory pattern acts as a remote builder, giving clients the exact tools they need right when they ask for them. Now, what happens when a brand new system tries to talk to a 10-year-old database? The older computer expects one set of communication rules, but the newer server uses completely different ones. You've likely solved a physical version of this problem if you've ever traveled internationally. You use a universal travel plug to connect your familiar laptop charger to a foreign outlet. In middleware, we handle this with the adapter pattern. It's a specialized piece of wrapper codes that surrounds an existing, older program, which we call the servant. Looking at this schematic, you can see the adapter positioned squarely in the middle. The client sends a request using its preferred format, labeled here as Interface 2. The adapter intercepts that request and translates it into Interface 1, the format the servant understands. Notice those small looping arrows inside the adapter block, marked pre-processing and post-processing. These loops handle the data conversion quickly as the program runs, meaning the system can adjust to unexpected changes in data formats without slowing down. By acting as an instant universal translator, the adapter pattern allows companies to keep using perfectly good legacy software alongside brand new technologies. Our final challenge is about maintenance in motion. How do engineers upgrade or modify a running piece of software without turning it off and breaking the connection for current users? Think of a smart digital toll booth on a highway. Instead of just taking a coin, this toll booth instantly scans your car and replaces your tires with upgraded ones while you are still driving at full speed. This concept is realized through the Interceptor pattern. It is a discrete module inserted directly into the communication pathway between the client requesting a service and the server providing it. This structural layout highlights the process. Notice in examples B and C, the direct straight-line connection between the client and the servant has been intentionally broken. The interceptor sits in the gap, analyzing the network message and adding new capabilities like security checks or data validation before sending it along. And if you look specifically at sequence C, you'll see the interceptor doing something even more complex. Here, it acts as a mini router. It takes one request from the client and coordinates multiple different servants to produce an entirely new, overarching function. Because of the interceptor pattern, network traffic becomes incredibly flexible. Engineers can adapt, secure, and route data on the fly without ever stopping the flow of information. So let's look at the toolkit we've explored. We have the factory safely building remote objects, the adapter translating between incompatible interfaces, and the Interceptor dynamically upgrading data pathways in transit. These 3 blueprints are the hidden mechanics running inside middleware. They provide the abstraction and flexibility required to keep our global networks fast and reliable. Now that you understand the individual patterns, you have the foundation to see how they combine. Next, we'll see how these patterns scale up to build a universal translator for computers. We'll explore tools like Corba, which bridges different programming languages, and the brokers that act like a digital switchboard to run programs on distant servers. See you in the next playbook entry.